Hello friends, today in this video we are going to learn about the application of integration. Integration. Integration has many applications nowadays. Among those, one is to find the area under the curve. So the application of integration is that we often do in studying while studying physics is your area under the curve. So we will find the area under the curve. Suppose this is, we take a graph. uh, we take a graph like this, and we have to find the area under this curve. So what is the area under the curve? This is x-axis, this is your y-axis, and this is y is equal to fx. Means y is a function of x. This is any curve, and you will have an equation for this curve. So this is any curve. We have to find the area under this curve. So what is the area under the curve? Means the area it makes under this curve is this. We draw vertical. Suppose this is point P, this is A, this is B, and this is C. So the curve is your PA, curve equation, and we have drawn here perpendicular lines from point P on the x-axis to the point C. Likewise, here we have drawn a perpendicular line from this point A on the x-axis at point B. So this area, this PABC, this area is under curve, and we have to find the area of this area under the curve. Now one question arises, we have many formulas for different types and shapes of the area. For example, a circle, a rectangle, a square, trapezium, all these are, but these are well defined. You cannot say that it is a well defined structure. If had it been those, we could have find the area as per our study that we have done up to matriculation, but it's not a defined area. It's not a defined area, so to find the area, we have to take the help of integration, and we will see how we can find the area of this under the curve PABC. So for that, we split it. We draw n number of strips. We divide this whole area in n number of strips. First, this is second, and this is third, and so on. This, suppose this is the last one. So this is your first, this is your second, this is third, and so on up to the nth. This is nth. We have drawn strips, various strips. Now it is similar to rectangle, isn't it? See here, this looks like. So we name it as P prime, P double prime, and P triple prime. We name it likewise, and this is suppose this is your x prime, x double prime, and x triple prime. We have drawn and divided it into n number of strips, but of equal width. Means the width of this is your delta x, and its width is also delta x, and each width is delta x. Means c x prime is your delta x, x prime, x double prime is your delta x. Likewise, each has width equal to delta x. Now it is similar to what? A rectangle. So if we are asked to find the area, we can find. For before that, we find the coordinate of point P. What is the coordinate of this point? This P prime. So coordinate of this P prime is what? P prime coordinate of P prime, its x coordinate. Suppose before that, one thing is, suppose this distance is a from here to here. From here to here, this distance is a, and the distance from here to here is your b. So this distance is b, and this distance is your a. Now what will be the coordinate of point P? Coordinate of point P, this distance is your a, and as y is equal to fx, this distance is your what? This distance is your p. This cp will be what? Fa. How? So its coordinate will be a and f a. Its coordinate will be a and f a. How? How its coordinate will be? This distance is your a, and this distance is your fa. Means here cp is y coordinate, as y is a function of fx. So cp will be fa. Why? Because y is a function of fx. So at particular value x is equal to a, the y will be fa. That's why this value is cp is your fa, and uh, that's why the coordinate will be, x coordinate will be a, and fa will be y coordinate. This is your x coordinate, and fa is your y coordinate. So this is your y coordinate, and this is your x coordinate. Likewise, we can find the coordinates of different points. If you are asked to find the coordinate of, p prime, what will be the coordinate? This distance will be x coordinate, and this distance up to here it is a, and this width is delta x. So on this distance from this is origin, suppose, so this distance will be a plus delta x. Its x coordinate will be this, and y coordinate will be f a plus delta x. So like this we can find the coordinates. Now p prime, and that's why likewise p double prime, the coordinate will be a plus 2 delta x, because up to here it is a, again delta x plus again delta x, 2 delta x. So p double prime is a plus 2 delta x, and it's f a plus 2 delta x. It's a y coordinate. Likewise we can find the coordinate of each point. Now we have to find the area. So area, so for the first rectangle, the what will be the area for the first rectangle? Area of first, it is rectangle. Now see this, this, and this, likewise this. Now this value is similar to the rectangle it is forming, but not exactly, because the area of first rectangle, by rectangle we mean, if we say p, uh, p, name it as p q, name it as q. So actually the area is, your rectangle is your p q x prime and c, but we have to find this, but we are finding this because we don't know how to find the area of this triangular shape. So area of first rectangle will be what? Your this value pc, pc, and into delta x, because this is your width and this is your height, length, you can say length and breadth. So pc into delta x, and what is pc? Pc you have got fa, so fa into delta x, this is your area of first rectangle. Again area of second rectangle will be what? This is this value, this value, this value is your, that is x prime and p prime, x prime p prime into delta x, and x prime p, x prime and p prime is your what? F, what is this? Up to here it is a, so f a plus delta x into delta x. So likewise you can find the area of the second, and likewise you can find the total area. So if we have to find the total area, then what will happen? The sum of first, second, third up to n. So total area A, total area A will be what? The area of first, and the area of first is your FA into delta x. The second is f a plus delta x into delta x, f a plus delta x into delta x, and again third is your f a plus 2 delta x into delta x. Likewise this will be the area of rectangle only, but in each term we are missing this area. The triangular shape remains left. This is not included in this. So it is not actually the exact area. It is not the exact area. it is equivalent to this. It is approximately equal to this, not equivalent. It is approximately equal to this value, but not exactly. Now you know how to write it in the form of sigma. You can write in the form of sigma. So area will be sigma you can choose up to here. So first term, you see in the first term you have a, and you don't have any delta x. So here I is equal to 1 to n, and f you can write uh, one thing before writing this. You can write the nth term. What will be the nth term? Nth term will be f a plus n minus 1 into delta x, into delta x. This will be your function. uh, Here you see the nth term will be n minus 1, because in the first term, in the bracket there is no delta x. In the second term you are getting first. In the third term you are getting 2. In the fourth term you will get 3. Likewise in nth term you will get n minus 1, because each term is getting by minus 1. First term, so here there is no delta x, so 0. In the second term, 2 minus 1. 1 delta x means 2 minus 1, so 1 delta x. In third term, 2 delta x. In fourth term, 3 delta x, means each term is less than 1. So nth term will be less than 1, and less by 1, and it will be a plus n minus 1 delta x into delta x. So this will be nth term, and we can write it in the form of sigma as like this. So in form of sigma you can write sigma I is equal to 1 to n, and fxi delta x. This will be in the form of sigma. You know how to write in the form of sigma. So this is the form we have written, this expanded form in the summation form. But this area what we are getting is not exactly the area of this uh, the curve, area under curve, because in each term we have a small triangle missing. So it is the actually it is less than the required area which we have to find. So how to eliminate those triangles? To eliminate those triangles, we need to take the help of the limit. The limit you know very well. So here area which is approximately equal to, we can write it is sigma I is equal to 1 to n, and f x I and delta x. This value is approximately, and we have to find the accurate. So here you can find that if you make delta x smaller, or you can say if you take the n number of these strips tends to infinity, then what will happen? The width delta x will be tends to 0. How? This is like this. Suppose this is your area, and this is your strips, the first, second, and so on. This is nth, and this is your delta x. Each width is your delta x. If number of terms increases, suppose this is 1 2 3 4, suppose we take 1 2 3 and 4 strips we have divided this whole area. If we increase the number of strips, suppose we increase the strips by 2 more, so what will happen? 6 strips, so it will be like this. Each term will be like this. So 1, 2, 3, 4, 5, 6, 7, 8, 8 strips. Now if we make an 8 strips, you see the delta x decreases. So in each term, if we make it double, so if the number of terms increases, now it's 16, so delta x has become very small. So number of terms goes to infinity, delta x will tends to 0 because n is going increasing, then delta x is decreasing. So n becomes infinity, then delta x will become infinity. And in mathematical terms, we can also find it as, here you can see, here you can see what is actually delta x. If you find the value of delta x, the delta x is your b. From here to here, this is your b, and here to here is a. So b minus a is your, this length is your b minus a, and this length has been divided in n number of strips. So each strip delta x will have width b minus a by n. So delta x value is b minus a by n. Now here you can see that if you increase n tends to infinity and n is in denominator and denominator goes to infinity, the whole value will become 0. So if n tends to infinity, the whole value tends to 0. So in mathematical form, here you can also see that as n tends to infinity, delta x will tends to 0. So if we increase the number of terms, we can easily decrease the delta x, and if delta x decreases, this triangle will decrease. How? You can see, if we make this, then triangle is smaller. In each term, the triangle becomes smaller. Now this is smaller. Again, if we increase it, this triangle will become smaller. And so with the decrease of delta x tends to 0, what will happen? This uh, triangular area will also, this triangular area which remains left in each term will also tends to 0. So triangular area tends to 0 when delta x tends to 0, and when triangular area is 0, this means that then at that point we will get the exact, because the disturbing factor is your triangular area. Due to triangular area, we are not getting the exact area in this equation. In this equation, we are not getting the exact area because of this triangle. And when the area of triangle tends to 0 is eliminated, then in that case we will have the exact area. So if we and to eliminate, if we increase the number of terms to infinity, automatically n tends to infinity, then delta x will be tends to 0, and in that case triangular area tends to 0, and in that case we will get the exact value of the area. So how we can write? And in that form we can use the limit, and with the limit we can write that if this is the condition, then we'll get the exact area. How? Limiting value delta x tends to 0, and this sigma I is equal to 1 to n f xi delta x. So this value now will give you the exact. How? Because now delta x tends to 0 means the triangular area will become 0, and in that case, and we know that how to find this, and this term is your called the integration and is also represented like this. So here we have limit, here is a is your lower limit and b is your upper limit. So here a and b is used for the symbol for the limit, because the area may go from anywhere to anywhere. So from where to where we are going? From a to b we are going in the area in the curve. That's why we take the lower limit a and upper limit b. and area under the curve will be A, and we represent it as f x dx, and this is your integration. So what is your actually integration? Integration is your, what actually we got the area we got the limiting value delta x tends to 0, sigma I is equal to 1 to n f xi delta x, and this is represented, this is the symbol from A to B, fx dx, and this is your integration. So with the help of integration we can find the area under the curve. So here we saw how to find the area under the curve. Now there are few methods with which we can, with the help of those methods we can easily find the integration. And also mathematics students will know, mathematics students would know that the integration is inverse process of differentiation. So the formula we have studied in the differentiation will work also in integration, but just in reverse form. For example, we have studied that the differentiation of sin x is your cos x. So dy by dx, where we can write y is your sin x, its differentiation is your cos x. So it's in your integration is inverse process. So if you integrate cos x with dx, you will get sin x. So there is no special formula. All those formula that we have studied in differentiation will be helpful in memorizing the formulas of integration also. So with these and there are also few techniques and formulas. With the help of those we can find the integration, and that will be in our next class. Thank you very much for the time being.